Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Muhammad Ismail Hakim. Today, I would like to share about Gc-Fid analysis to evaluate the possible adulteration of extra virgin olive oil with a different vegetable oil. For start, I would like to introduce our presenters. First, we have Muhammad Ifat bin Muhammad Anapiah, Muhammad Haiman Zakawi bin Hairul Zulaiman, Muhammad Omar Haziq bin Abu Bakar, and Muhammad Amar Hakimi bin Muhammad Zaini. Experiment gas chromatography or GC is used laboratory technique to analyze the chemical composition of oil and pure EVOO, extra virgin olive oil. Extra virgin olive oil has a unique profile made up of specific fatty acid, sterol, and other compounds. If olive oil is mixed with other vegetable oils such as soybean or sunflower oil, GC can detect it. Because vegetable oil, broadly defined as oils extracted from seeds or plants, it produces a distinct chemical pattern. EVOO is made by mechanical pressing ripe olive, and this careful process helps preserve its special qualities compared to regular olive oil, particularly its natural phenolic compound, which contribute to its quality, stability, and health benefits. In this experiment, we have our objective, which is in this experiment is about checking if extra virgin olive oil (EVOO) has been mixed with other cheaper vegetable oil such as sunflower oil, soybean, or palm oil. This mixing is called adulteration. In this experiment, we use peanut oil (PO), sunflower oil (SO), soybean oil (SOO), extra virgin olive oil (EVOO), refined corn oil (CO). Also use palm oil (PAO), 1.25 HAL in methanol, and lastly Gc-Fid in hexane.
For methodology, the materials that we use is Gc-Fid and hexane, hydrochloric acid, fatty acid methyl ester, and some edibles or samples such as corn oil, peanut oil, sunflower oil, soybean oil. For methods, we prepare 4 mixture with EVO, extra virgin olive oil, mix 1, 5% and 5%, mix 2, 10%, mix 3, 25%, and mix 4 is 50% of vegetable oil. So the total mass of each mixture is 10 gram. So the VO amount for mix 1 is 0.5 gram, mix 2 1 gram, mix 3 2.5 gram, and mix 4 5 gram. For methods number 1, sample preparation, we take 0.2 gram of oil mixture and put it in a Pyrex test tube with a screw cap. Number 2, chemical reaction. Add 2 ml of hydrochloric solution in methanol and heat the tube in water bath for 60 minutes, and this will break down the triacylglycerol and convert them into film. And for number 3, extraction of film, add 2 ml of distilled water, 1 ml of N-hexane, and the film will dissolve into organic solvent. For number 4, purification, filter the organic phase using 0.5 micrometer PVDF string filter. And lastly, Gc-Fid analysis, take 1 microliter of purified film solution and inject it into GC.
Now we move to the result. The first one is EVOO, extra virgin olive oil. This chromatogram shows extra virgin olive oil. The largest peak is peak 18, which corresponds to oleic acid, and a peak in the middle of the chromatogram. Next, smallest peak include peak 12, palmitic acid before it, and peak 20, linolenic acid after it, which is typically for extra virgin olive oil. For the next one is this graph represent peanut oil. The main peak is also peak 18, oleic acid, located in the middle region. However, additional peaks appear at the end, such as peak 21, aracidic acid, peak 27, benzoic acid, and peak 34, lignoceric acid, which are characteristic marker of the peanut oil. Next, for corn oil, the dominant peak is peak 20, corresponding to lignolic acid, located in the later middle part of the chromatogram. The oleic acid peak 18, is smallest, indicating a high polyunsaturated fatty acid content. The next one is sunflower oil. This chromatogram shows sunflower oil. The largest peak is peak 20. Lignolic acid appear in the later middle region. The oleic acid peak 18 is much smaller, confirming sunflower oil as a pure rich oil. Next, in soybean oil, the lignolic acid is peak 20, is large and appear in the later middle region. This is following by a discrete peak 24 corresponding to alpha lignolic acid, which are key marker for soybean oil. Next is finally this chromatogram represent palm oil. The largest peak appear early and is peak 12, corresponding to palmitic acid. The oleic acid peak 18 appear later with lower intensity, showing that palm oil is rich in saturated fatty acid. In conclusion, difference in dominant peak number peak 18 for extra virgin olive oil, peak 20 for seed oil, and peak 12 for palm oil allow clear differentiation between the oil.
This is data for pure extra virgin olive oil. Palmitic acid value is 14.19, oleic acid is 63.16, linoleic acid is 12.39, arachidic acid is 0.35, alpha linoleic acid 0.6, while lignolic acid is 0. Then for extra virgin olive oil with peanut oil, palmitic acid is 10.8, oleic acid is 66.2, linoleic acid is 11.14, arachidic acid is 0.74, alpha linoleic acid is 0.42, while lignolic acid is 0.74. For extra virgin olive oil plus corn oil, palmitic acid is 12.8, while oleic acid is 45.82, linoleic acid is 33.6, arachidic acid is 0.37, alpha linoleic acid is 0.71, while lignoceric acid 0. For extra virgin olive oil plus sunflower, palmitic acid is 10.78, oleic acid is 46.19, linoleic acid is 34.55, arachidic acid is 0.28, alpha linoleic acid is 0.35, and lignoceric acid is 0. For extra virgin olive oil with soybean oil, palmitic acid is 12.21, oleic acid 43.62, linoleic acid is 31.46, arachidic acid is 0.39, alpha linoleic acid is 3.24, lignolic acid is 0. For extra virgin olive oil plus palm oil, palmitic acid 35.15, oleic acid 46.31, linoleic acid 9.68, arachidic acid 0.26, alpha linoleic acid is 0.28, while lignoceric acid is 0.
Extra virgin oil or EVOO is a victim of adulteration by various low-priced vegetable oil by manufacturers to cut costs while outputting huge stock of counterfeit EVOO at a fast rate. This can pose a significant health risk as adulterated EVOO may contain undeclared allergen and low nutritional value of a pure EVOO. Most common oil used in adulteration are soybean or rapeseed oil. Various techniques is used to detect adulteration such as spectroscopy and ultraviolet visible near-infrared absorption spectroscopy and near-infrared hyperspectral imaging. GC analysis is used to determine the concentration of fatty acid within the sample to determine its authenticity. Pure unaltered EVOO contain free acidity of below 0.80%, which is expressed as percent of oleic acid. Using the pure EVOO as a standard, the result of sample can be compared with the standard to determine its authenticity. This is a graph of percentage ratio of oleic and inoleic. When compared to the pure EVOO standard, we can see various vegetable oil will alter the ratio by increasing it or decreasing it.
This decrease and increasement of the ratio can be used to determine if the sample has been adulterated or not.
So, to conclude the video presentation, Gc-Fid is a reliable method for fatty acid analysis. According to the result, extra virgin olive oil contains about 63.16% oleic acid and 12.39% linoleic acid, giving a high oleic-linoleic ratio of 5:10. In comparison, vegetable oil such as corn oil show much lower ratio of around 0.58 when extra virgin olive oil is mixed with vegetable oil. This ratio decreased and additional fatty acid appear, making adulteration clearly detected. This is all the references that we use to making this our video presentation. That's all from us. I hope you guys enjoy with our video presentation. Thank you.